Scientists indeed possess data regarding the potential area where a future eruption of the Yellowstone supervolcano might occur, and such information is causing serious concern among researchers worldwide. All conclusions are based on large-scale scientific work and a detailed analysis of information accumulated and studied over many years. Supervolcanoes, like Yellowstone, are unique natural structures, and their name was not created for the sake of loud phrasing, but to reflect their true nature. Such eruptions are thousands of times more powerful than the ordinary volcanic catastrophes humanity has witnessed throughout history. When an event of this magnitude occurs, the planet faces global consequences capable of fundamentally changing the familiar face of civilization. One can imagine powerful earthquakes causing massive destruction, followed by enormous magma ejections, and then the formation of giant clouds of volcanic ash capable of blocking sunlight for weeks or even months. The sky becomes gray and heavy, which has a serious impact on the climate and ecosystems over vast territories. An acute food shortage arises as agriculture becomes practically impossible without sunlight. Aviation ceases to function, transport systems become paralyzed, and certain animal species and entire forest ecosystems may disappear forever. One disaster triggers the next like a chain reaction, destroying the habitual way of life for millions of people and animals. All this looks like a scenario of a frightening future. However, such a picture is presented not as a fantasy or an apocalyptic prediction, but as a conclusion based on scientific assumptions. But when exactly could this happen? It is important not to panic here, because despite the alarming descriptions, we are not talking about events of the near future. When eruptions of ordinary volcanoes occur, it is always a serious disaster, but its consequences are most often limited to the regions located near the epicenter. If you mentally increase the scale of such destruction thousands of times, you can imagine the potential power of a supervolcano eruption, which could certainly have a serious impact on global ecology and climate. Yellowstone is considered one of the largest volcanic systems not only in North America, but in the entire world. Over the last approximately 2.1 million years, it has erupted 3 times, and each of these events had extremely large-scale consequences. The last eruption occurred about 640,000 years ago, and then volcanic ash covered an area comparable in size to half of the United States. Fortunately, at that time, people did not yet inhabit these territories. However, natural ecosystems suffered serious damage, and many species of plants and animals were never able to fully recover. An event of comparable scale occurred about 74,000 years ago, when the Toba supervolcano in Indonesia caused global climate changes and destroyed many ecosystems. There are hypotheses according to which humanity was then on the verge of extinction, and only a small number of people were able to survive the conditions of the so-called volcanic winter, although these data still lack final confirmation. Since Yellowstone is a huge volcanic system located within a national park, it was extremely important for scientists to determine from which area a potential future eruption might begin, as this knowledge is necessary to assess possible risks. Studies have shown that the magma under Yellowstone is not concentrated in one reservoir, but is distributed between several underground chambers, each of which could theoretically show activity. One such reservoir, located in the northeast of the region near a scenic area known as the Sour Creek Dome, is considered the most potentially active. In this area, red-hot magma interacts with deep mantle rocks located at a significant depth, and the extremely high temperature allows it to remain in a liquid state. For a clear explanation, scientists use the comparison with a heating liquid. If the heating process continues and there is no cooling, the liquid begins to rise and may overflow the container. Similarly, the magma in this area does not cool and could theoretically begin to rise upward, resembling a fountain of boiling mass. Magma reservoirs are located at a depth of about 6 miles from the Earth's surface, and this entire zone is characterized by an extremely high temperature. For their study, the magnetotelluric method is used. This method is based on an analysis of the interaction of the Earth's magnetic field, formed by the rotation of its core, with electrically conductive materials in the planet's interior. Magma containing molten minerals has high conductivity, and its presence can be determined using sensitive instruments working on a principle resembling a metal detector. Using magnetotellurics, researchers scanned the Yellowstone area and identified 4 large magma reservoirs. 3 of them showed similar characteristics, but the 4th reservoir, located in the northeast, showed more pronounced anomalies, which attracted special attention to it. It is this site that is considered as a potential site for the start of an eruption in the distant future. However, fortunately, such an event is not expected anytime soon. According to the most cautious estimates, it may occur only in tens of thousands or even hundreds of thousands of years, so there are no grounds for immediate alarm. Magma does not have a clear timer, and the volcano does not activate at a preset moment. Magma slowly seeps through the porous structures of solid rocks, like water passing through a spongy material. It gradually fills the pores, accumulating, and it is believed that to start an active eruption, it is necessary to fill a significant part of this space. Currently, only about half of the required volume is filled. However, hot rocks continue to heat the magma, keeping it in a liquid state and allowing it to move. Over time, magma can connect with other reservoirs, forming larger flows that will begin to rise to the surface. It is practically impossible to prevent such processes. Theoretically, one could try to cool the magmatic masses, but they are at a huge depth, have a colossal temperature and volume, and any intervention could lead to unpredictable consequences. All that remains for humanity is to accept the existence of natural processes and be prepared for possible consequences. In the case of a hypothetical eruption, the process would begin with a powerful release of energy, the destruction of the Earth's crust over the magma reservoir, and the formation of a giant caldera. The shock wave would be so strong that it would destroy all life nearby, and ash and porous rocks would be ejected to enormous heights in a matter of minutes. Then the ash column would begin to expand, plunging large areas into darkness. Red-hot particles would settle down, heating the air and making breathing extremely difficult, and hot rock fragments would cause fires, forming pyroclastic flows that destroy everything in their path. Within the first 24 hours, ash could cover a significant part of the territory of the USA and Canada, causing power outages, water pollution, and the death of crops. Precipitation would turn the ash into a toxic gray mass containing heavy metals such as mercury, arsenic, and lead, poisoning the soil, water, and air. Even after the completion of the main phase of the eruption, sulfur dioxide would continue to spread in the atmosphere, forming an aerosol veil that prevents the penetration of sunlight and causes a global temperature drop of several degrees. This would lead to crop failures, rising food prices, economic crises, and the risk of mass starvation. Years later, the temperature would begin to recover gradually, but returning to familiar climatic conditions would take decades. Humanity would have to rebuild cities, restore agriculture, and adapt to new conditions of existence. Nevertheless, even with such a development of events, it is assumed that humanity will be able to survive if it maintains the ability to cooperate, mutually support, and adapt. Therefore, if such a catastrophe is possible only in the distant future and does not depend on the will of people, it remains to value every day lived, be grateful for the present, and help each other, because it is precisely solidarity and mutual assistance that can become the key to survival even in the hardest times.